data set. But if we have time, we can talk further. I can talk about BERT.
Yeah, good enough, good enough. Whatever you want to talk about is perfectly fine. This is no, whatever you wrote in the speaker profile is not important.
Yeah, so I was responding to Ritu, Mr. Murthy. She's the person who's asking the questions. So let's get started. I'm sharing my screen here. Can you all see, I mean, Mr. Murthy, can you see my screen? It's basically a Jupyter Lab.
I can see it's a presentation, yeah, background and all that. Okay, I'm going to go mute if you, it's a good idea for me to go on mute so that you are talking unless, I'm needed, you just say something, I'll come back.
I will, okay, thank you.
Yeah.
All right, guys, let's get started. Thank you so much for joining. So this is a talk about GPU training. I mean, we have about 30 minutes. Typical any GPU training that you do, it takes a lot more than 30 minutes. So how am I going to do this demo? So the best way is for me to sort of walk you through all the nuances and all the challenges of GPU training. But at the same time, I'll also try to start some of the training sessions, but I'll stop them because each training session takes long, upwards of 15-20 minutes, right? So, here's a quick agenda. So I'm going to give you a background about what to expect in these next 30 minutes and followed by a quick overview of the platform that I'm using. And we get into the actual hyperparameters and training details, followed by the most important topic when you're doing GPU training is memory management. How do you handle your data, your memory, your objects that are in cache as well as that are allocated as part of your GPU memory? How do you handle all that? And I'll talk a little bit about some few final thoughts, and we'll leave the last 5-10 minutes for question and answers. Okay, so let's get started. So as some of you might be aware, the guy from OpenAI as well as the Tesla, Karpathy, has released this new tiny library called MinGPT. It's basically for those of us who don't have dozens and dozens of GPU missions, but we still want to experience what's a GPT training is. So he created this MinGPT almost like a month and a half, 2 months back. And in fact, it was told that he just built this over a weekend. So I'm going to base my demo or my talk based on this MinGPT code base. As you can see, the original GPT is on the left side, like a battleship with so much functionality, right? Whereas the MinGPT is like this tiny, dingy little boat, right? So that's really what I'm using as part of my demo here. As part of that repo, I'm picking only one particular problem, which is character level language model development. He has given three other examples as well, but I'm not touching that as part of this. And finally, this talk is limited to PyTorch only. So whatever I'm sharing, whatever commentary I'm providing is limited to PyTorch. Not all of them are relevant to TensorFlow or Keras and so forth. Okay, so those of you who are wondering, okay, where do I start? Everybody like Google, Amazon, Microsoft, Azure, all of them are offering GPU infrastructure for you. So where do you start? How do you start? The ideal place to start is look for infrastructure that is very easy to use, right? You don't want a very complex infrastructure setup that's going to take just weeks and weeks just to set it up, configure it, and install settings and so forth, only to realize that you're wasting your valuable business time doing all that. Similarly, you should look for infrastructure that's very transparent in their pricing model. That's really important, right? It's going to be very expensive, right? And you had to constantly do this training to really improve your model and improve your outcomes. So you want to pick something that's very transparent in their pricing and very cheap. That's definitely something you should look at, because this may, the initial training that you do is only going to sort of help you quickly get to your production deployment. And you don't have to limit your training infrastructure same as your production infrastructure. So you can sort of find cheaper alternatives, quicker alternatives to do your training, so that you build your model, and then you can stick with your enterprise production infrastructure for later on deployment. And finally, you want to start small and you slowly, progressively want to build it, right? So as part of this demo, I'm using 4 2080 Ti GPU machines. So if you can see, here's my terminal, and this is so these are the 4 GPU machines I'm using. And right now, as you can see, there's not a whole lot of GPU memory in the cache or being used because I have not ran any programming yet. So this code is exactly what Karpathy's code is. So I'm not making any changes to this part of the section. So I'm just going to run some of these sections. So as you can see, this is using PyTorch and NumPy. This is the class that actually handles some of the character preprocessing of this character language model. Here he set up the block size as 128. This block size is basically tied to pretty much all the other classes that we are using, the trainer configuration, GPT config, as well as a char data set. It's basically basically helping us select how much data, what is the block size of the data set we are using. And for this particular example, he has used Shakespeare's text. Again, I did not make any changes to this. I'm using as is. So this is about 15, about what is the size of it? It's about 1.1 million characters, about 65 unique characters in the entire data set, right? So that's a data set I'm dealing with. So it's fairly small data set compared to most of the real world problems that we all deal with. Again, the point is to just show you what to look for and how to build a GPU training. So one of the most important aspects of GPU training is, learning about some of these hyperparameters and how do you set those parameters based on the limitations or capabilities of your GPU infrastructure, as well as the algorithms, as well as the framework that you're using, whether it's PyTorch or Keras or TensorFlow. For example, obviously the number of epochs that you have to run to build your model or train your model is directly proportional to how long your training has to go on. If you select 2 short epochs, then you are undertraining. If you are too many epochs, you are overtraining. So you have to find a balance there. So that's something for you to think about. And the second aspect is a batch size. This is one of the most important parameters that impact your ability to do your GPU training. In fact, I'll try to show you that by creating a failure and demonstrate that as part of this talk as well. So we'll get to the batch size later on. Just to give you a sense of what the size of the model I'm trying to train here, I'm using about, it's building 12 neural network layers, and it has about 12 heads. Those of you who are familiar with the transformers and the BERT architecture, this has about 12 heads. No, I'm sorry. This has about 8 heads, 8 heads and 8 layers. This is the code here. What I was referring to about 12 heads and 12 layers is actually the GPT-1 model, which used about 125 million parameters, and they used about 12 layers and 12 heads, right? Whereas in my demo here, I'm using 8 layers and 8 heads. So much smaller. But if I run this should tell me the number of parameters I'm using in this, about 25 million parameters. Just to give you a comparison, GPT-1 trained against 125 million parameters. That's GPT-1. We're not even talking about the 2 and the 3, which are much larger, right? So now let's go ahead and kick the tires here. I'm gonna run this training script, and I have set maximum epochs to 1, and the batch size to 512. Learning rate, again, I'm sure most of you are familiar with some of these parameters. I will touch on wherever it makes sense. Otherwise, I'll leave them as is. The warm-up tokens, as you might be aware, after that many tokens, the learning rate starts to get modified. Okay, let's run this and see. So hopefully it should kick off the training. Okay, so the training kicked off. So when the training is going on, obviously within this particular session, since I can, if I run any other command, it'll just wait until the training is over, right? So the best way for me to figure out, what is my utilization, one way of doing that is using one of the Unix commands called top, right? So this sort of tells me at least some of the CPU utilization here, right? So you want to sort of keep an eye on this, make sure that your CPUs are not getting clogged, just want to make sure that everything is working fine, right? So one of the things you notice here is a CPU percentage. You might be wondering, how come the percentage is over 100, right? So by default, it gives you the percentage of utilization when you have multiple processors running. It's still only considering that one CPU is in consideration. So to address that one nuance, I think there is a shift I will give me the toggle to switch to per CPU utilization. Now it changed to about 13%, right? So anyway, so that's one way of doing it. But I'm gonna kill this guy, and there is something called Hstop. I don't know. I've not installed Hstop, but there is a way. Yeah, so I should be able to install it using apt-get. So let me quickly install apt-get Hstop. It gives you a little bit more colorful, a more detailed view of your memory utilization, especially from a CPU standpoint. Now, if I run Hstop, so this gives me a bit more clarity, a bit more details on all the processes that are running here. These are all my Python 3.7 processes that are running here. That's taking up this one training I kicked off here. So as you can see, I can. So we are about 15% into the training. I've started this about 3-4 minutes back. So if I continue this training, it'll train through the entire talk session, right? So that's not really ideal for us. So at some point I'll kill that guy. In fact, maybe this is probably a good time. But yeah, let me go ahead and check the some of the utilities that Nvidia provides. Nvidia out of the box provides me a management utility called Nvidia SMI that tells me what is my GPU utilization. So I believe I ran, I didn't run this command before, but so as you can see, about 95% of each of these GPU machines are getting utilized, 95%, 92%, 90%, right? So this is one way of doing it. And there's also a much detailed log for those of you who want to explore this further. If you pass -a as a parameter, it gives you a detailed NV log of all the GPU missions. We have 4 GPU missions, as I said before. So this is the entire log of it. It sort of tells you whether your jobs are running uniformly across all the GPU missions or not. Is there any cloggers that are impacting the performance of a particular GPU mission? These are all the things that you can sort of do as a back of the hand validations, right? So this is the NVSMI log that you can see. So now what I'm going to do is I'm going to, and those of you who are relatively new to NVIDIA SMI utility, so it gives you a couple of really interesting data bits, right? One is the memory usage. Memory usage is the memory allocation on GPU out of the total memory. That's what's giving you when I run this command here. So it's giving me about 91% is on the GPU utilization. But if you see this ratio, this is the memory utilization out of the 11 GB. I think I'm looking at about 7 GB on that mission. I think it's approximately 7 GB on all the missions, right? Okay, so that's memory utilization. GPU utilization is a percentage of GPU utilization. What is how much of that GPU's kernel is being used across each of those 4 GPU blades that we have here set up. Apart from that, the rest of them, it's all right. For example, display A is basically telling whether you are using the GPU to display or not. In this case, we are not. So it should show it as not applicable or off. Oh, it's showing it as off, right? So other than that, here you have the specifications, basically the GPU, which type of the GPU machine you're using, and also the temperature of these machines. I never had to really pay attention to the temperature, but if you're running your GPU machine for a long time and maybe that temperature goes abnormally high, you wanna sort of pay attention to, right? So anyways, going back to the training here, we got about 37% training done here. Before I get to trying any of the commands, I'll let it continue, right? So as I said, memory management is the most important part of GPU training, right? So first of all, what gets stored in the GPU memory? A lot, right? So for example, especially when you are doing deep neural networks, pretty much most of the model parameters, in fact, all the model parameters are getting stored in your GPU memory, and that includes the weights and biases of each of the layers in the deep neural network, and any of the optimizer variables. Let's say you're using some kind of Adams optimizer or whatever. All the variables that are being part of the optimizer are being stored on the GPU memory, and also you generate a lot of intermediate data, right? As you know, deep neural networks is computationally intensive. There's a lot of math computations happening, so all that intermediate data has to be stored somewhere. So all that is stored on the GPU memory. And finally, any of the local variables, the kernel, and some of the kernel implementation, let's say in this case PyTorch, any of the relevant variables that are part of the PyTorch are also stored in there. So the most important aspect that you need to think about is how is your infrastructure getting impacted by all this memory storage, right? And are you able to train the models with the batch size that you really care about? Because remember, batch size is everything, right? So that could make or break your model performance, model accuracy, and you don't want to be hamstrung by the limitations of your footprint, and you're producing a model that is suboptimal or not consistent with your expectations or your business expectations primarily, right? So you want to sort of think about that, and that's the reason. Most of the developers, who are just getting into the GPU, so they are not. What they need to do is they need to make sure that they address doing some cleanup of some of these data. Of course, you got the garbage collector that comes out of the box that can handle some of this for you, but especially when you're training large models that takes a lot of time, then there are times when you want to clean up. You want to do some your own cleanup at the end of each loop, right? So those are all things that you need to think about. So here are some helpful utilities that PyTorch provides, right? Let me go ahead and pause this training now. I'm going to pause the training. So yeah, it finished about 56%. My purpose was not to do complete training because, I want to just talk about some of these challenges and give you some pointers as to how to address as part of your GPU training process. So now that we stopped that, so let's quickly go and check how is my SMI report showing up. So obviously the wallet under the GPU utilization is 0, right? So the processes are not being used. But on the other hand, if you see the memory footprint, the memory usage, there is still a lot of memory sitting there, right? So even though we stopped the training, so let's get into how to get some of those details. So CUDA, using PyTorch utility, you have this function called memory stats that gives you details about all the utilization by device. So in our case, we're using 4 devices, 4 GPU machines. So I'll run this one for the first device. As you can see, this sort of gives me a footprint of how much of the memory is allocated, how much is current, how much is freed. It gives you a lot more details than I can process, right? Honestly, but at least this is how you start to debug and hack through as part of your GPU training. Unfortunately, each of these utilities are different for the frameworks that you're going to use. For example, tomorrow you're going to use a TensorFlow, Keras, or MXNet, CNTK. These are all have their own ways to do the memory management, right? So you want to sort of think about understand the reality and slowly hack through the problem. And that's kind of what I do for a living. So similarly, if you want to understand how much of the memory is cached, this is the maximum memory cache. So it started telling me about 6.9 GB of memory is cached. And how much of the memory is allocated. It's about 6.8 GB of that memory is allocated. And these terms are very specific. In fact, I have added those definitions here for those of you who are wondering what memory allocated versus memory cached are. I will not go over those definitions in the interest of time. We got only 9 more minutes here. But the good news is I will share this Git repo with you all, and you'll be able to read all my notes in there at a later point. The CUDA, there are a few other utilities I dropped here. Again, what I did is I took Karpathy's Jupyter notebook, and I dropped all these helpful memory tips in there so that you could take this and actually train his model and improve your GPU training knowledge and skills. So here's a script I got from somewhere online. I have put their reference here as a courtesy because I'm just using as is. This basically gives me a footprint of each of the GPU missions, how much memory is utilized here. So it's GPU 1, 2, 3, 4. Okay. Similarly, again, so I will not run all these utilities, but each of these give you like pretty good granular details. For example, let me just run this one just to demonstrate. This actually allows me to look up all the tensors that are utilizing some of this memory and how much space is being utilized by these tensors. Again, it's a lot more for us to process as humans, but you had to sort of hack through this, and I'm going to skip through hacking of that output at this point in the interest of time. Going down, it's a long output. So there is, of course, the garbage gc.collect is one way of sort of cleaning some of this, but even if you run that, it does not give you, it does not clean everything, right? So, there's also recommendations on best ways to use a garbage collector. So I'm not saying that let's go ahead and do gc.collect at the end of each of your program. There are specific recommendations on how best you use garbage collector. For those of you who are Python experts, can vouch for it. Here's another utility that I picked up that sort of gives you the overall total memory available, how much is free, how much is used. So this tells me that I got about this much, about 3.7 GB of memory available, and about 7.7 GB of memory has been utilized. And CUDA PyTorch also offers this this utility called empty cache. it will release some of the GPU cache, but there's still a lot of variables that it cannot remove from the cache, especially if they are being used by the tensors or some of the remember the model parameters we talked about. Some of that is still going to be there. It will not completely empty the cache. So you need to sort of do further processing of it as part of your training. And going down the list, yeah, so those are some of the memory techniques that I have typically used, and I've added a lot more than what I'm covering here. The intention is you would take these snippets and drop them into your GPU training to learn and debug how the memory is being utilized, right? So I'll leave that as a take home for you guys. Now going into the next phase here. Remember I said the batch size and the number of GPU missions definitely has a big dependency on your training. For example, right now I'm using 4 GPU missions. If I change my batch size to something bigger, it might actually crash. So let's go ahead and do that to just prove that hypothesis. So here, so I have batch size of 512. I'm going to change that to 1024 and see what happens. So there you go. It basically crashed. It gave me a CUDA out of memory error, right? So so the maximum batch size I can use with this particular setup, with these particular GPU cards is about 512, right? Going down. So what I have left here is a bunch of experimental data for you. So you know, you at least have a sense of, you know, how much what should be the batch size based on the neural networks, number of layers and number of heads that you have configured. So those are all the features is definitely important, number of layers is important, and the amount of data that you're processing is important. These are all the things that you should take into consideration as part of your training. So this is basically generating text based on the model that we trained. I'm not going to run this this particular part of the training because I shut my training, so which means the model has not been built. So this might not even work if I run it here. This is from a prior output. Okay, so for those of you who are going to run it, you'll see the output there. So for now, I'm going to skip that part. And yeah, so we got about 2 more minutes. I want to just get to the final comments and share a few more insights about this platform I'm using. So people wonder, hey, you know, what about Apache Spark? You know, can I not use Spark instead of GPUs, or can I use GPUs instead of Spark? From some of the best practices I have learned over time is if you are dealing with massive amounts of data, oftentimes, you know, a Spark is the ideal option. Whereas if you're dealing with lots of computational complexity, especially you're building a deep neural network with multiple layers and multiple heads, then the preference is to build using GPUs. You could do one or the other. And there are also infrastructure right now, I believe as part of Spark 3.0, GPU accelerator workloads are considered as the first-class citizens, so which means you'll be able to leverage GPU infrastructure as well as part of Spark 3.0. I mentioned about Python garbage collection already. I'll skip that. Of course, multi-threaded programming is definitely preferred. That way you can easily process and manage some of these memory-intensive activities, something for you to think about. Oh, I believe I have written a small CPU stat snippet as well somewhere here. Yeah, this one. This sort of gives you what is the CPU utilization at the end of this. You should see. Yeah, so what is the percentage of CPU utilized? How much is the physical memory? And other gory details here. Okay, so again, quickly moving on. So I'm using this platform called TrainML.ai, which is a very simple user-friendly platform for me to sort of do my training. So if I go to TrainML.ai. So it's basically a serverless deep learning model training infrastructure. The best part is I don't need to install a whole lot or set up the environment. Out of the box, it comes with this base environment. It comes with the Docker infrastructure. Of course, you have to have Docker running for you to do some of the computation. But you could also launch it right from the browser. In fact, I'm going to show you how to do that. And it also comes with a well-installed GPU packages right out of the box. So all the major packages such as TensorFlow, PyTorch 1.5, MXNet, LightGBM, all these come with this infrastructure. So it's pretty neat, user-friendly. And also it gives me a very transparent view of how much I have used so far, how much is remaining. For example, let me see. I'm gonna log into my account now to, it tells me how many credits are right here. It tells me how many credits I have. It comes with public data sets as well, most popular data sets, and the founders are actively adding new data sets as well. Okay, so how are we doing on time? 1 minute over. Mr. Murthy, do I have to stop right now, or can I take a few more minutes to talk a couple of minor?
Yeah, go ahead, because the next one is 10 minutes between each talk.
Okay.
We put artificial buffer so that if you go for 5 more minutes, 8 more minutes, still be okay, because the next person comes in, wants to start on time and wants to make sure that.
That's true. Okay, that's great. So, so then I just want to cover a couple of more pointers here. I was fortunate enough to convince the founders to give some offer for those of you who are attending this particular talk. The founders have agreed to give a free trial about 200 hours of GPU time for those of you who are attending this demo. So I'm gonna share this link in the chat message, and those of you who are following through this demo can go to that location and sign up. Let me see how I can I add? Okay, so yeah, so chat. So I have added the offer details there. So you just need to create an account and enter this really cool coupon with my name in it.
Wow.
I've become famous, and off you go, off the races. Basically, and the best part is I have set up a very simple Git repo for all of you to follow through this, right? Demo, I went through this in like 30 minutes. It's not fair. There's only so much you can glean from 30 minutes of talk, right? So I have set up a special repo for all the audience of this particular talk. That gives you pretty much all the details I covered here. And here's a Jupyter notebook that I have used as part of this demo. And you can just download, clone this repo, and off to races. You should be able to train this entire model and even produce this output, which I'm showing here. I know I have not ran that because I didn't complete the training of the model, but I'm hoping all of you get to test run this and experience the simplicity of this this platform and this particular repo. So I will stop there. We got about maybe
we have some questions also. You can go to Q&A.
Yeah, sure.
I'm eager as attendees have some good questions. I already saw it.
Sure. Yeah, so it's a loaded question, right, Stephen? There are definitely some of these larger behemoths, whether it's GCP or Google or AWS or Azure. You know, they have their own bells and whistles. I have actually tried to train the similar models on TPU, and it was really painful to get this exact model working on TPU, because I had to go through a lot of upgrades in the infrastructure, and even after that, I couldn't get that to completely work. I've also trained on AMLS and AWS. Those worked out pretty decently. I've used on SageMaker and also in Azure. I but it all depends upon where your corporate infrastructure is pointing to. So if your corporation is already using AWS or your enterprise, then it's a no-brainer to go with them because all your data is already there. Remember, data has gravity. So if your data is already sitting in one of these cloud providers, if I were you, I would just use their GPU platform. But if you don't have that kind of situation, you are a smaller outfit, and you want to like really get into it and get into training, then you should look for smaller players such as TrainML, which is very nimble, very quick for you to just set up an account and run with it. So question regarding best practices on how often to clean GPU memory. So it's also a very loaded question. So if I go back to my Jupyter, this thing, so there are various ways of cleaning it, right? So the good news is if your code is already report, and if your data is also accessible, you can kill things, you can restart things so many times, right? For example, here I can go into the kernel and just shut down the kernel and restart. So that cleans up a bunch of stuff, right? But at the same time, even if after you do that, if some of the model parameter data is still residing there, then you would have to do some kind of a garbage collection cleanup. gc.collect is one way of doing it. As I said, it's a process in identifying what you want to keep, what you don't want to keep. And for example, I don't know how many of you are familiar with the checkpoint process, right? Every time you are training, you want to save these checkpoints, right? When you are the bigger players, they save all the checkpoints. Whereas for a smaller player like us, I try to save the first and the last, or the last and the best checkpoints. Only 2 checkpoints I save, because that way I'm not hogging up my memory with thousands and thousands of checkpoints, right? So there are many ways to sort of deal with memory and utilization. What specific tasks are solved with MinGPT, and in example, did you fine tune or pre-train? Great question. So for this particular one, it's a generative model, right? Basically, we trained using characters, and we're generating character text. In fact, I'll try to see if I can run the last part of that script. Chances are it will fail because I don't have a saved model here. So, but basically, I'll show you before I run. I'll show you the output. That way, at least you know what it is. It's basically generating text, Ritu. That's what this model does. Basically, so where is it? Okay, right here. So I'm passing a string, oh God, oh, it's a Shakespearean text, right? So it's generating this text based on its understanding of how the characters are structured in the original corpus, which is a tiny Shakespeare document. So I will try to run this right now. Chances are it'll fail because I don't have a working model, right? Unless it's pulling from a checkpoint version. While that's doing its thing, let me, looks like it picked up at least a checkpoint model, right? So there you go. So which means I could probably try a few more examples for you. So if I say, instead of oh God, oh, yo, what's up, right? Yo, what's up? So obviously there's no such phrase called what's up in Shakespeare, right? So let's see what happens. What's up? Okay. How will it process that? It should still handle it, so yo, what's up, this fool? But she's a wonder. Yeah, it's made, at least if you see all the words, all these are proper words, they are not like garbled words or anything, so it's still handled that pretty well, right? So I hope that answers the question, Ritu. And what else? Yeah, I think that's the last question. Are there any other questions?
Yeah, I think we are getting to the exact time for the next presenter. I really appreciate your eagerness to provide us a lot of information. I know people have asked you questions. They can always pursue more with you, one-on-one as well. We encourage that. We just have to make sure everyone gets to speak. That's the thing. Thank you a lot, Vamsi. It was very good presentation. You took a lot of interest to go into details. We like that.